Hello everyone. This video is about lesson number 9, which is over power. The learning objectives of this lesson is to define power and explain its relationship to work and energy, and to state the unit of power and to explain it in terms of the fundamental units. And we need to be able to solve problems that involve various forces, including gravity, to evaluate power. And we need to define the unit kilowatt hour and its relationship to power and energy. And finally, we need to be able to calculate the kilowatt hour of problems that involve power and time of several appliances. Now we learned that work is force times distance, and work enables us to change energy from one form to another. Power has to do with the rate at which the work is done. How fast can you do the work? So the way we rate machines and appliances is not only by how much energy they consume, it's by how fast they do the work they are required to do. So power is work over time. So it depends on two factors: the work, the bigger the work, the bigger the power, and the time. The shorter the time, the bigger the power. Now what would be the unit of power? Since power is work over time, it will have unit of work over unit of time, which is joule over second. And that's what we call it watts. So watt is defined as the power output of 1 joule of work per second. Hence, for example, 100 watts means 100 joules per second. So if you have a machine or a light bulb that has power rating of 100 joules, this means it has the ability to perform 100 joules of work per second. Now let's look at some problems that involve calculating power due to the force of gravity. So how much power is required to lift a 1 kilogram mass a distance of 1 meter every second? Now to lift 1 kilogram, you have to apply force equal to the weight of that object. And to find the weight of 1 kilogram, you have to multiply the mass by acceleration due to gravity. So the first thing is to find the force, which is the weight of the object, because you need to apply force equal to the weight of that object to be able to lift it. So 1 kilogram times 9.8 will give you the force that needs to be applied. Then you have to multiply it by the distance in order to evaluate the work. So you multiply 1 kilogram by 9.8. This will give us the force times 1 meter. This will give us the work. And then to find the power is work over time. So we divide by the time, which is 1 second, and this will yield 9.8 watts. Now let's look at some problem similar to that. And problem number 1 here is similar to the lab we are doing this week. Suppose you are given the weight of a person in pounds instead of Newton, and you are asked to find how much power in watts does that person expend in doing work against gravity by running up a flight of stairs that are 8 meters high in 5 seconds. So again, power is work over time, and to find the work, you have to multiply the force by the distance, and the force has to be in Newton. If we start with the power is work over time, and to find the work, we have to find the force and multiply it by the distance. Now the force has to be in Newton. To get the work in joules, the force has to be in Newton. So we have to convert 130 pounds to Newton. Here the force is against gravity, so the force has to be equal to the weight of that student. Now we know that 1 Newton is 0.2225 pounds. So to convert 130 pounds to Newton, we have to divide by 0.225. And this will yield 578.5 Newton. So now we have the force that the students need to apply, or the students need to exert, in order to be able to climb the flight of stairs. After we found the force, we have to multiply it by the distance to get the work. And the distance here represents the height of the stairs, which is 8 meters. And this will yield 4,628 joules. Then we find the power by dividing the work by the time, and this will yield 925.6 watts. Okay, so in this type of problems, when you're asked to find the power, you have to go through several steps. You have to find the work first, And in order to find the work, we have to find the force. Now, sometimes the force could be given in Newton, so you don't have to do anything. You just multiply the force in Newton by the distance. Sometimes the force will be given in pounds, so you have to convert the pounds to Newton. Sometimes you'll be given the mass in kilogram, and you have to multiply by 9.8 to get the weight in Newton in that case. Now, another type of problem that involves the unit kilowatt hour. Okay, before we introduce the unit kilowatt hour, let's talk about unit of power in general. As we mentioned, power is equal work over time or energy over time. We know that energy unit is joule and the times unit is second. So power is joule over second. That's the unit of power. And we call this unit watt. So 100 watts light bulb, for example, means this light bulb can consume 100 joules of energy per second. Now we have other units other than watt. We have horsepower, which was measured by James Watt in the coal mines. He attempted to measure the power done by a horse, and he found that the horse will perform 746 joule of work per second. So we call this unit 1 horsepower, which is 746 watts. So if you have a machine that has power rating of, let's say, 10 horsepower, 10 horsepower means 7,460 watts, which means this machine has the ability to perform 7,460 joules of work per second. Now, in addition to horsepower, we know kilo of anything is 1,000. So 1 kilowatt is 1,000 watts. Now, from this equation, if you look at this equation of power, we can write an equation for the energy. Let me use a different font color here. Energy, we can write it in terms of power times time. Since power is work over time or energy over time, then energy is power times time. Now, if you use watt here for power, and if you use second for time, watt times second will give you joule. And joule is a small unit. Joule is not a big unit, it's a small unit. Now, the electric company charge us with a unit much bigger. Instead of using watts here, they use kilowatt. And instead of time in seconds, they use time in hours. So here, kilowatt, which is 1,000 watts. And instead of second, the time will be in hours. And we know 1 hour is 3,600 seconds. So the unit, instead of joules, it will be in kilowatt hour. And kilowatt hour is unit of energy. It's not unit of power. Kilowatt is unit of power. Notice here, kilowatt is unit of power. When you multiply it by time, it will become energy. It will become unit of energy. And kilowatt is around 3.6 million joules. Because you have 1,000 here out of the watts, kilowatts is 1,000. And you have 3,600 seconds for 1 hour. So 3,600 times 1,000 will give you 3.6 million. So that's around what kilowatt hour is equal to. So to solve a problem like this one here, we are asked to find the electrical energy in kilowatt hour. So we have to make sure that the power is in kilowatt. So we have to convert the power here from watts to kilowatt. And we have to make sure that the time is in hours. So we have to convert 4 minutes to hours. And then by multiplying the power in kilowatts by the time in hours, we'll get the energy consumed in kilowatt hour. So always in this type of problems, you have to convert the power to kilowatts and you have to convert the time to hours in order to find the energy consumed in kilowatt hour. Then if you're asked to find the cost, and you are given the rate here, the rate is 12 cents per kilowatt hour, and let me use a different font here. So to find the cost in dollars, for example, you have to multiply the energy consumed, and the energy has to be in kilowatt hour, by the rate. You have to multiply it by the rate at which the electric company is charging you. And here we are given the rate to be 12 cents per kilowatt hour. To convert 12 cents to dollars, this is basically $0.12. So you have to multiply it by the rate in unit of dollar per kilowatt hour. So you can see here when you multiply the energy in kilowatt hour by the rate in dollar per kilowatt hour here will cancel out with kilowatt hour, and you'll get the answer in unit of money. So let's go ahead and solve this problem here. So you can see here in this problem, first we convert the 1250 watts to kilowatts. And to do that, you have to move the decimal point 3 places to the left. So this will give you 1.25 kilowatt. Then to convert minutes to hours, you have to divide by 60. And this will give you 0.067. Now you can multiply the power in kilowatt by the time in hours. And this will give you the energy consumed by this microwave in kilowatt hour. So that's the first part, which is finding the energy consumed in kilowatt hour. In the second part, where we need to find the cost, and usually we are given the rate, we should be given the rate. So to find the cost, we multiply the energy consumed in kilowatt hour by the rate in unit of money per kilowatt hour. Kilowatt hour will cancel out, as you see here. And 0.08375 times 0.12 will yield $0.01. This is around 1 cent. Okay, let's look at more problem here in the homework. And let's look first at problem 6 here in the homework. In problem 6 is similar to the problem 2 that we solved, problem 2 in the discussion exercises. The only thing, we are given 2 appliances instead of 1. So we are given here a coffee maker that was used for 40 minutes, and microwave oven that was used for 12 minutes. And we are given the power rating of each one. The coffee maker is 1650 watts, while the microwave is 1250 watts. So here we have to do the same steps for both appliances. We have to convert the power in watts to kilowatts for the coffee maker and for the microwave. We'll do it separately. And we have to convert the time from minutes to hours. So for the coffee maker, 1650 watts, we have to divide by 1000 to convert it to kilowatts, meaning we have to move decimal point 3 places to the left. So this will give you 1.650 kilowatts. We'll do the same thing with the microwave. 1250 is 1.25 kilowatts. Then we do the same thing with the time. We convert 12 minutes to hours, so we divide by 60. 12 by 60 will give you 0.2 hours, and 40 minutes is 2/3 of an hour. And then we find the energy consumed for each appliance. So this is the kilowatt, which is the power of the coffee maker, times the time the coffee maker operated. So this part here will give you the energy consumed by the coffee maker. And then also we find the energy consumed by the microwave. So 1.25 kilowatts times 0.2 hours. And then we add them. So we have the energy consumed by the coffee maker in kilowatt hour, the energy consumed by the microwave in kilowatt hour. We add them, and this will give you 1.356 kilowatt hour. So that's the total energy consumed by both appliances. Then we calculate the cost. We are given the rate to be $0.08 per kilowatt hour. So we have to multiply the energy consumed by the rate in dollar per kilowatt hour. So 1.665 kilowatt hour times the rate will yield $0.0108, which is around 10.8 cents. That's how much energy consumed, assuming the rate is $0.08 per kilowatt hour. Let's look at the other problems in the homework. Problem 1, what is power? We know power, we can write as work divided by time or energy divided by time. Notice that kilowatt hour is unit of energy, it's not unit of power. If it's kilowatt, kilowatt is unit of power. But kilowatt times hour will be unit of energy. Yeah, you see here kilowatt is unit of power. And what's brought from the electric company is electric energy. The kilowatt hour is unit of energy. Now let's look at question number 5, which is similar to question number 1 in the discussion exercises. You are given the weight of the student in Newton. So here you don't need to do any conversion. We are already given the weight in Newton. And we are given the height of the stairs. And we are given the time taken for this student to climb up the stairway. And we are asked to find the work and then the power. So to find the work, we have to multiply the force by the distance. And here the force has to be equal to the weight. In order for any person to climb certain flight of stairs, he or she has to apply force minimum equal to their weight. So since the student weighs 556, that's the force he needs to apply. That's the force he exert times the distance, which is 4 meters, and this will yield the work. So the work done by the student is 2,224 joules. To find the to find the power, he has to divide this work by the time taken, 25 seconds, and this will yield 88.96 watts. So this is his power output, assuming he did this amount of work in 25 seconds. I hope you found this video educational. Let me know if you have any questions. Thank you.